A critically important part of any information systems security program is managing access control. In many cases, we could say that information security is primarily about access control. Who can get access to our systems and data, and what can they do when they get there? Now, system access could be simply at a read-only level, that all you can do is read the data, but you're not able to actually make any changes to it. However, another layer or another level of system access would be if a person has write access. Now, in some cases, a job or a process might be able to write data even though it can't go and read that data later itself. We also have the level of privilege that indicates if a person can execute a certain function or whether or not they can perform a certain type of action. Can they create new records, or can they merely look at existing records? Are they able to delete records or even things like tables or databases? Or do they have full, absolute control over the system? These are all different levels of access, and it's important that we ensure that a person's level of access is appropriate for what they need for their job responsibilities. Access controls, therefore, can be physical. Do we let a person into the room or into the building? They can be certainly at an operating system. Does a person have administrator level access to this system? They can be to an application. Can a person log in to this application? Now, good access control is quite often done through central management rather than decentralized management. The reason for this is that if we manage access centrally, one department that manages it for all systems, networks, buildings, and so on, then we have a consistent level of access control all the way across the organization. This ensures that we don't have some areas that are well protected and others that aren't. But you can also understand there are some serious risks associated with centralized management. That means that everything is dependent on the cooperation, support, flexibility, and response times of that central management. If that central management requires network access for our systems to be able to validate if a person should have access, and that network goes down, it could be that nobody is going to get access to our system for a time period. But access controls are something that we as auditors should be looking at carefully. We should check to see whether or not access rules are correct, and that whether or not people are required to use a unique user ID on the system. We don't want people sharing a user ID. Then if something goes wrong, we don't even know who actually did that task. No, the identification of any person, process, or we could use the term entity on our system should be unique and should be then only issued through a trusted process. So a person cannot get access to our system if they are not an authorized individual. Now, sometimes we will group people that have similar job responsibilities. We'll call this role-based access control. So people that have more or less the same needs for access, we group them together so that we can facilitate the administration then of their access. That's very different from a rule-based access control system where each person's access is managed independently for that individual. We also, of course, have to put in place that tracking and logging so we know what did somebody do when they're on the system. This is also the reason why the identification should be unique, so we can associate that activity on the system with the individual that then performed that activity. This is the process we often call accounting or even auditing. Just because a person says that, hey, I'm Joe, doesn't mean they're Joe. We need to prove they are who they said they are. Identification is a person states who I am. Authentication is they prove or they validate that they are who they are. So it's that verification or validation of the identity that was then offered or claimed by that individual. There's three main ways we do authentication. We often use a secret, or what you know, such as a password or a passphrase or a certain, response to a challenge. We can use what you have. Do you have an employee ID card? Do you have a token, a smart card? Do you have an RFID chip? Something that then you have in your possession that could validate, well, for example, a very simple one is when you cross the border and you have to offer a passport. The passport states that you are who you say you are because you have that passport in your possession. And of course, the third way, often called biometrics, is what you are, where we look at a person's physiological characteristics such as a fingerprint, an iris scan, or a retina scan, or we look at their behavioral characteristics, signature dynamics, keystroke dynamics, voice prints, the way they do things. Those are behavioral then biometrics. But none of these authentication processes, what you know, what you have, and what you are good enough on their own. We always encourage that people use at least two of them together. Use a PIN number plus a token. Use, for example, a password and a biometric. That is what we'll call then two-factor, or often called strong authentication. So, first of all, the person says, I'm Joe. They prove they're a Joe by knowing Joe's password and having Joe's token or smart card. But now that they've been authenticated on the system, we give them certain levels of privilege. And this, of course, is authorization. What are their permissions, privileges, or the rights that they are now granted as an authorized user or process on the system? This is where we bring in those concepts known as need to know. If a person doesn't need to see it, don't show it to them. For example, we all see that today with credit cards. You go and you make a purchase in a restaurant. At the end of the meal, you pay, for example, with a credit card, but that slip of paper that is your receipt does not show the entire credit card number on it. Waiter or waitress working in that restaurant, they don't need to know your credit card number, so we don't show it to them. We obfuscate it, we mask it, and only show, say, the last 4 digits. That's, of course, an enforcement in a very practical sense of need to know. That way, that waiter or waitress could not steal or misuse your credit card data, even if they wanted to, because they don't have access to it. However, there's another element that comes in here we call least privilege. Now, least privilege usually comes after need to know. Let's say, for example, you're a customer service representative and a customer calls in and says, I need to change the expiry date on my credit card. The customer service rep maybe can only see the last 4 digits of that credit card. They say, sir, is that your 0000 card? And the customer says, yes, that is that card. Okay, sir, what is your new expiry date? At which point the customer service rep can enter in or can modify the expiry date. But maybe they cannot change the credit card number. Maybe they cannot, for example, enter in a new credit card or delete the one that's there. We've given them a least privilege. What are their rights or permissions now that they have a certain level of access to the system? And least privilege is a very important part then of a good security program. Quite often it can be explained this way. Least privilege is only to give a person the level of access they require in order to do their job, but also only for the time period that they actually require it. If they don't need to have that access on the weekend, maybe their user ID doesn't work on Saturdays or Sundays. We also then limit a person's level of authorization with principles such as separation, or sometimes called segregation of duties. Separation or segregation of duties means we break a task into individual parts, and different people have to execute each part. One person could input data, but another person would have to approve it. And that, of course, is a way to then detect, but also hopefully then prevent mistakes, or of course, even fraud. This is often done through things such as, we can say here, dual control. Dual control says it takes two people to open the safe. One person knows the one combination, the other person knows the other combination, and both of them have to work together each morning to open the big vault for the bank, the safe for the bank, for example. Another way to implement separation or segregation of duties is through mutual exclusivity, that says if a person input data, they would not be allowed to approve it. A person may be able to both approve and input data. However, they would not be allowed to approve the data they had input. They could only approve data somebody else had input. Those two actions, inputting and approving, are mutually exclusive. We also discussed just a moment ago the idea of time-based access control. This is often called temporal isolation. It's where our access restrictions are based on time of day or maybe even day of the week. Does your access work 24 hours a day? Or perhaps maybe a certain user's access is only good during normal business hours. Outside of normal business hours, they couldn't get in. You take even with a bank. Very often the safe on the bank has a time lock on it. When they close that safe at the end of the day and spin the dials, it's not possible to open that vault again until the start of business the next business day. That's a form then of time-based access control. Now, this could also restrict a person's access based on where they are. If the person is in the office, their level of access might be higher than if they're working remotely, for example. An example of this also could be, say you want to do administrator level functions on a server or an IDS, a network appliance. Quite often, in order to do administrator level functions on those devices, you must be physically hardwired to then the administrator port on that device. Management of, say for example, an intrusion detection system cannot be managed by the network that IDS is monitoring. No, the only way to then manage that IDS is to be physically connected to the administrator port. An example of this from the mainframe, of course, is the operator console. The operator console is a hardwired connection from that console to then the CPU. It's a trusted path that's not networked or connected to anything else. So we put in access controls for employees, but we also need access controls for customers. The level of access that our employees have is usually far greater than what a customer has. An employee could see the data for all of our customers, whereas a customer could only see the data for their account. For example, a business partner may have access to some of our data, but maybe only into an extranet, or there's some type of external network interface that they can connect to that doesn't allow them complete access to our data in behind. We often do this with contractors and consultants. Their level of access is more restrictive than, for example, a normal user. We try to ensure they only have access, for example, to the network segment or the project that they are actually working on. Now, the exception to all of this, of course, are auditors. In many cases, an auditor is allowed to request access to almost everything. They can request access to different systems, but even when an auditor requests access, that access should be done through a formal approved process to make sure that the access is only granted according to the rules and policies of the organization. When that access is no longer needed, it should be taken away. So even though a person might have high-level access, they should only have that high level of access for the time they actually require it.